Okay, but first I'm going to look at a couple problems from homework 4-6. And I need you all paying close attention. We have a test on our horizon, and it is going to be a biggie. Right now, you're all sitting pretty because you haven't had many grades and you got a lot of homework grades and little quizzes. A test goes in and your grade can change drastically. So it's time to start really focusing and gathering all this in. The question is, what's the period of this thing, and is it sinusoidal? Well, the period of this part of the function is 2 pi divided by 3. 2 pi because it's a sine, and divided by a 3 because that's the number that's in there. And then likewise, the period of this one is 2 pi over 3 because it's a cosine divided by 3. These match. That means the period of the whole problem is 2 pi over 3, and it is sinusoidal because they match. That's how you tell if they're sinusoidal. The period of each piece is the same. So then the next one said this. Now, there's a lot of numbers. I'm looking at this right here first. There's a lot of numbers in there, but only one of them matters for this question, and that's this guy right here, because that's the guy that changes the period. So this is a sine, so its period is 2 pi divided by 5. This is a tangent. Its period is pi divided by 5. They do not match, so it is not sinusoidal. However, it is periodic. It does have a period. The whole problem has a period. This one repeats itself every 2 pi over 5. So it starts over again at 2 pi over 5, 4 pi over 5, 6 pi over 5, and so on. That's when that one starts over. Every 2 pi over 5, it repeats. This one repeats every pi over 5. So 1 over 5, 2 over 5, 3 over 5, and so on. The first time they both repeat together, so the first number they have in common is their period. Well, don't they both have a 2 pi over 5? Yes. So the period of the sum is 2 pi over 5. Okay, got it? Okay, now look at the, in your pile of review stuff, the pages have numbers on them. I'm not sure if the numbers make any sense, but go to the one numbered 6. Up in the corner it has a 6. It says quiz 4145 review at the top. Okay, so here we go. We're finding the exact value of cosine 5 pi over 3. Now, some of you have issues with exact value. That means by hand. That is not type it into your calculator. Exact means your answer is a radical. Okay, probably a radical. So, what's 5 pi over 3? What's pi? 180. 180 divided by 3 is 60 times 5 is 300. Okay? So this is the cosine of 300. So 300, remember, angles in math land, not on a compass, this isn't a compass, but angles in math land are labeled this way. So 300 is all the way down here. Right? Now, here's the key. Use your common sense. This is 300 degrees right here. How much is this? 60. logic 60. Which means this is root 3, this is 1, and this is 2. And that is negative. Okay? This is all old news. If you are hopelessly confused, you go back and watch some videos. Okay? All these e-learning days and all that, you guys really need to stay focused. Okay, we want cosine. What's the cosine in this picture right here?
1/2.
1/2. Adjacent over hypotenuse. The answer is simply 1/2. Remember, you're going to have to be able to do this without a calculator. Okay, next, tangent 270. Now, that's a little problematic because where's 270?
On a line.
On a line. And when they're on a line, and what she means is right here, this is 270. When they're on a line, when the angle is on a line, we call it quadrantal, you cannot draw a triangle. So I can't do this problem like I did that problem. So what I have to remember is, okay, this circle has a radius of 1, so what does that make this point? If I come straight down 1 unit.
1.
0, -1. So in other words, my x is 0 and my y is -1. Tangent, by definition, is y over x. So putting my y over my x, I get -1 over 0, which is undefined. Cosecant 5 pi over 6. Well, what's 5 pi over 6? 150. Pi is 180, divided by 6 is 30, times 5 is 150. So this is the cosecant of 150. So that's going to be over here. This is the key to the whole problem right here, this angle. So use your common sense. That's 150. So what would this part have to be? 30. Because this is 180. So we have 1, 2, root 3, and that root 3 is negative. Now what's cosecant? Cosecant is reciprocal of sine. So it will be hypotenuse over opposite. So hypotenuse over opposite is 2 over 1 or 2. Cotangent, 5 pi over 4. 180 divided by 4 is 45, times 5 is 225. 225 right down here. How big is my reference angle? That's this little angle right here. How big is he? 45. So I have a 1 root 2, and both of those are negative. You have to pay attention to which quadrant you are in. Okay? Cotangent is adjacent over opposite, so won't that just be 1? Put that in your backpack. Donovan? Okay, now we're going to come up with some numbers and sketch. So what you need to know before you start doing this is that the shape of a cosine is like a skateboard ramp. You start up here, woo, that's a cosine. And a tangent those are the basic shapes. That's what we're going to be drawing with whatever changes are in the equation. So y equals -3 cosine 2x minus pi over 5. So what's happened to my cosine? Well, a couple of things have happened. First of all, it's going to be upside down. And second of all, it's not going to start on the axis. It's going to start over here at pi over 5. So I have the upside down of that shape starting here. All right with everybody so far? So the only thing left to do really now is fill in the labels. I stuck those vertical labels in. Now I'm going to put in the rest of my labels. Remember, the cosine is going to stop right where it started, at the bottom of the valley in this case. So what's my period? Well, it's supposed to be 2 pi, but what have I done to it? Divided it by 2. So now the period is pi, which means that from this hand to this hand is pi. So to find that label, I'm going to take 1/5 and add it to 5/5. So this is going to be 6 pi over 5. 1 1/5. I start at 1/5 and add 1. 1 1/5. Now this will be the middle of 1/5 and 6/5. Well, when I find the middle, I add and divide by 2. I average. So 1 and 6 makes 7/5, and half of that will be 7/10. I don't want to do decimals. So I'm finding the average of 1 and 6. 1 and 6 is 7/5, and then times a half, 7/10. All right, now I gotta do the same thing here. This is 2/10 and 7/10. Adding that together is going to make 9/10, right? And half of that is 9/20. So this arithmetic really causes you really have to know how to find midpoint. You add them and divide by 2, or add them and multiply by a half. So 7/10 and 12/10 is 19/10, and half of that is 19/20. So, what is all this information I have to fill in? My period, I already did. My period is pi. My amplitude is 3, not -3, 3, always positive. My phase shift is pi over 5. That's my horizontal shift. It's where I started, pi over 5. My frequency is the reciprocal of the period, so the frequency would be 1 over pi. And my vertical shift is, I don't have one, it's 0. 0 vertical shift. Vertical shift happens when you put a number on the end, right? Picks the picture up or down. We didn't do that. And then y equals 1/2 tan, 1/3 x. Now this particular tangent does not have a shift of any kind. It's not going sideways or up and down, and so it is situated exactly where it's always situated, right here at the origin, just like that, because it has not been shifted, has not been moved sideways or up and down. What has changed is the period. The period of a tangent is normally pi. But this one has been divided by 1/3, so its period is 3 pi, that means that between my hands is 3 pi. So what are these labels? This is the origin.
3 pi?
No, this is not 3 pi. Between my hands is 3 pi.
3 over 2 pi.
So doesn't this have to be 3 halves, 1 1/2, and this is negative 1 1/2? The whole thing is 3. Period is the whole thing. So since the origin is right in the middle, we have to go 1/2 this way and 1/2 that way. Right? All right, what's the amplitude of that picture? No amplitude. The only functions that have amplitude are sine and cosine. Everything else is no amplitude. Period's 3 pi. Frequency would be 1 over 3 pi. Phase shift and vertical shift are 0. You don't have any in this problem. Alexis?
So what if there was like a vertical shift? How would that change the picture?
It wouldn't move the asymptotes, it would just move the origin.
Okay.
So, or point, that point would go like up 2 or whatever.
Okay, so it was like a phase shift, the asymptotes would also just
Yes,
move
the
it.
asymptotes will shift if there's a phase shift, because that moves it sideways, right? All right, change 3 radians into degrees. All right, this one's a little harder. You've been changing radians into degrees a few times already today, but this one's a little harder because there's no pi in it. So you can't just plug in 180. What do we do when we can't just plug in 180? Pi over 180 equals 3 over x. Won't that do it for me? So pi x equals 540 and x equals 540 over pi. That's it. Now, number 4, same thing. Pi over 180 equals x over 18. Now, does everybody understand why the x is where it is in these 2 different equations? This is pi radians, 3 radians. 180 degrees, 18 degrees. So 180x equals 18 pi, and x equals 18 pi over 180, which is just pi over 10 when we reduce it. All right, find the arc length if the radius is 10 and the central angle is 10 degrees. Who remembers, this is like from day 1 of this unit, who remembers our little formula for arc length? Anybody remember it?
Arc length equals radians plus
It's not plus though, it's times. Radius times radians. So arc length equals radius times radians. Okay, so it's a trick problem because a lot of people just memorize, okay, I take the radius times the angle. That's what you do, but the angle has to be in radians. So we can't do this problem until we change 10 degrees into radians. So pi over 180 equals x over 10. We just did that with a different angle. You're changing a degree measure into a radian measure. So 180x equals 10 pi, and x equals, looks like pi over 18. Now that's not the arc length. What's pi over 18? The radian measure of the angle. So then the arc is going to be radius times radians. So 10 pi over 18, which is 5 pi over 9. And there aren't any units in the problem, so you don't have to worry about it. But if this were inches, if the radius were inches, the arc length would be inches. Okay, it's a two-part problem, radius times radians. If you don't have radians, you need to get radians, which is what you did. All right. Now, same picture, but this time, the angle's pi over 6, and the arc length is 2, and you have to find that, the radius. 2 equals pi over 6 times r. Does that make sense to you?
What's the plus 5? Oh, no. I thought that was a plus.
You okay, Alexis?
Yeah, I just
Okay.
realized it's an S.
Why was your hand up there?
Well, I mean, since I think that
Okay.
I
So-
was wrong.
So would we all agree that arc length equals radius times radians? So I just need to figure out what r is. So won't I times by 6 and divide by pi?
Yeah.
So 12 over pi is my radius. Not a pretty number, but it doesn't matter. That's what it is. Little word problem. These were in the beginning of the chapter and at the end of the chapter. We're kind of finishing all that up today. Find the length of a shadow cast by a 16-foot pole if the angle of elevation is 27 degrees. Now you have to be able to draw that picture. Does anybody have a question about why I put a number where I put it? Okay, so now we have to write an equation, and you're gonna pick whether you want your equation to be a sine, cosine, or tangent. Those are your only choices. Please don't do something weird. Sine, cosine, or tangent. So what do you think? Tan. Obviously it's tan, as you know. Opposite over adjacent. So 16 over x. You're solving for x, so that means you gotta get it by itself. So 16 divided by tan 27. Now I wrote my calculator to somebody. So I gotta make sure I'm in degrees. And then 16 divided by tan 27.
31.4017.
So 31.40 feet would be our answer. Okay? And last one. We're gonna find the cosecant. And we know that the tangent is -3/5. Now, what does this 90 less than theta less than 180 do for me?
You know it's not less. Did you know it's in
It has to be in the second quadrant, exactly. Because in math land, this is 90 and this is 180. So if you gotta be between 90 and 180, which is what that says, then you are in quadrant 2. Okay? And the tangent is 3/5. Now be careful, in that picture, it's the 5 that has to be negative, isn't it?
Yes.
What's your hypotenuse? A squared plus b squared equals c squared. What?
Square root 34.
Square root of 34. 25 and 9. Now we want cosecant. In this picture, cosecant. Cosecant is reciprocal of sine. So it's hypotenuse over opposite, root 34 over 3. Okay. Next time I see you, we're going to have a quiz, and the quiz is going to have this stuff on it, plus the stuff I reviewed from the homework that a lot of you screwed up on. That's sinusoidal period stuff, okay? No, everybody's clear on that. That's our quiz, okay? On next time I see you, whatever day that is. Okay, now, get your notes out. We want to finish those up. And while you're doing that, I suppose some of you are going to be heading off on retreat, so I'm going to go ahead and hand out some notes and things for the next week. Probably. Oh yeah, they definitely are. At the end of next week. Or, yeah, probably next Friday would be, yes. But I'm not ready to say that just yet. All right, everybody got one of those. Now, put these two things away. We're not using this today. These are for another day. I don't want you to have them in possession. All right, did everybody get two things? All right, now we're going to finish up our notes. So we're actually on our last page of our old notes, page 48. And we're going to do problem number 4. So everybody's paying attention. We're doing problem number 4 on page 48 of our notes. So here's the situation. A large helium-filled penguin. All right. So here's the ground. Here's the penguin. And he's got cables holding him up. You've seen the Macy's parade and whatever, those big balloons. They have cables holding them up there so they don't fly away. So one of the angles is 48 and one is 40. And they're in the same plane. Okay, if the cables are attached to the ground 10 feet from each other, so this is 10. How high above the ground is the penguin? So how high, I'll call that H, above the ground is the penguin? Now, we need to be very careful about something, because our natural inclination is to say, okay, this is 5 and this is 5. But that is not the case, is it? How do I know absolutely 100% that those are not equal? Is he? Exactly. This triangle is not isosceles, and so the altitude will not bisect the base. Now, I have no idea how long each of those pieces is, but is it true that this piece I might call X, and this one would be 10 minus X?
Yes.
Is that true? Okay. So could I say that tangent 48 equals H over X? Right here in this little right triangle, because I dropped it perpendicular. Tangent 48 equals opposite over adjacent. Is that true?
Yes.
Now, that doesn't really do any good because it has too many variables, but it's true. Similarly, can I say tangent 40 equals h over 10 minus x? In this triangle. Is that true?
Yes.
Get this out of there. Now, what do I have here, guys? I have two equations and two unknowns. Just like you had in first year algebra, they're ugly little equations. But what did you do in first year algebra and second year algebra and earlier this year when we had a system of equations? What?
You pick one of the values by themselves.
You
just like
substitute or you eliminate. Right. In this case, elimination is going to be really tough, so I think I'll substitute. So if I multiply my x over here, h equals x tan 48. And if I multiply this over to here, and I'm going to distribute, so 10 tan 40 minus x tan 40 equals h. I'm just multiplying this over here. So tan 40 times 10, tan 40 times x. Now they both equal h. See that? So what does that mean? They equal each other. So now I have an equation, and the only letter in it is x. That's a solvable equation. Now you're looking at it thinking, what? Let's put the x's on the same side. The x's now are on the same side. I just added this one over here. And now I'm going to factor that x out. So I'm going to take out the x. Oops. Tan 40 is just a number, so let's not be confused by it. It's just a number. All right, so while some of you are catching up, let me go back through our steps so far. The question is, how high is the balloon? So we dropped our altitude, split this into two right triangles, and said, okay, the tangent of 48 is opposite over adjacent, the tangent of 40 is opposite over adjacent. So then we took each of those two equations and we got h by itself. So we multiplied x over, multiplied 10 minus x over. Set them equal to each other. If they're both h's, they're equal to each other. Put all the x's on the same side of the equation and factor them out. So this is where we are right now. How do we get x equals?
You divide by the tan 48.
Exactly. So 10 tan 40 divided by tan 48 plus tan 40. Now, do make sure that when you divide, because we're ready to type it in our calculator, when we divide, this has got to be in parentheses. So you're dividing by this parentheses right here. So let's make sure we can all get the right answer there, and then we'll talk about what to do next. So 10 tan 40 divided by parentheses tan 48. Now, do be careful because as soon as you're going to type parentheses tan 48, but as soon as you type tan, it puts a parentheses right here. You got to close it after the 48 and then plus tan 40. Did you get, well, you tell me what you got.
I got 4.3.
4.3037? If you didn't get that, let's try it again. So we all should have a calculator out. This way, we all should have a calculator out. We all should be typing this right here. And if you get 4.3037, you're on target. Okay, if we were on Zoom, you would all put their little yellow thumbs up. Let's see who's getting 4.3037. Now, we're all excited because we just typed a massive problem. We just typed it in. That's not the answer to the question, is it?
No.
The answer to the question was H. So I want you to look right here. What did you tell me H equal? H equals X times the tan of 48. So isn't X this number on your calculator? Isn't that what we just got?
Yes.
So to get the answer to the problem, we're just going to take this guy and hit times tan 48. And the balloon is 4.78 feet above the ground. Is that what you got?
Yes.
That was a big one. That was a big one.
What was the answer supposed to be for the division?
4.3, I think. Now, if you're struggling, if you still don't have it typed in correctly, first of all, make sure you're in degrees. And then come to office hours on Monday. Go to the Learning Commons, find a friend, but get it figured out. Because what a shame to do all that work and then not get it right because you typed it in wrong. All right, number 5, here we go. From a point 100 feet from its base, the angle of elevation to the top of this thing is 34 degrees, 13 minutes, 12 seconds. How tall is the monument? Well, this is a breeze after what we just did. What's this?
Tan
Tangent.
34 degrees 1312 equals the,
Isn't this an easy one? Compared to the one we just did?
yes.
So we'll just multiply by 100 and type it in. So let's all try that. Good practice there, typing in these fragmented degrees. 100 tangent, 34 second angle degrees, 13 second angle minutes, and 12 alpha plus 68.01. I thought somebody said that already. 68.01 feet. Oh, we could do those all day. All right, number 6. The angle of depression from the top of the Smoketown Lighthouse is 120 feet above the surface is 10 degrees. How far is the buoy from the lighthouse? So where are we putting the X?
The base.
The base.
Tangent.
So take a look at that picture. Again, it's an easy one. Does that make sense to you? The picture. So Alexis already said it was a tangent. Would you agree with her? This one's a little different though because the X is in a different place. So we'll have to multiply the X over and then divide. I got 680.55. Anybody else get that? Okay. We have one more to go. it looks like it might be a whopper. Might be another one like our penguin balloon problem. Let's see. From the top of the 100-foot building, a man observes a car moving toward the building. So the guy's standing up here and he looks down here and he sees the car. His first angle is 22 degrees. But the car is moving toward the building. So after a little while, now the car is here. And when he looks down, that angle is 46. So take a look at my picture. Make sure you understand what's happening. The car originally is here, then the car moves to here. And we want to know how far the car travels. So this right here is the answer to the question. Does everyone understand that? Then,
Did you repeat that one more time?
huh?
Did you repeat that one more time?
Repeat what?
Why is that?
The question says how far does the car travel? So he starts here and ends here. So that's X. That's what I'm looking for, that distance. Now, I want you to look at this carefully for a second. In this triangle right here, the 46-degree triangle, if I call this distance A, could I find it? Can I find that A? What would my equation look like for this triangle right here? Tangent 46 equals 100 over A. Is that true? And so, this is not going to give me the answer to the question, but it is going to give me that distance. So 100 over tan 46. I'm not going to type that in just yet, but are you still with me? You see what's happening there? Now, look at the big picture. Look at the whole triangle. Pretend for a second this isn't even in there. Can we find this? I'll call it B.
Yes.
In the whole triangle now, isn't the tangent of 22 100 over B?
Yes.
So the tangent of 22 equals 100 over B. So B equals 100 over tan 22. Would you agree with me there? Okay, so now I got A and I got B, neither one of which is the answer to the question. How can I get X? B minus A. So X is going to be 100 over tan 22 minus 100 over tan 46. Does that make sense to everybody? So instead of finding what I really wanted, which was over here, I found the little base of the little right triangle and the base of the big right triangle, and then I'll just subtract them to get the piece I need. So 100 divided by tan 22, do not forget to close those parentheses, minus 100 divided by tan 46. Did you get 150.94? Okay. All right, that takes care of that. So the 4-8 homework will be due on Tuesday, same day as we have our little quiz. And since you know what's on the quiz and we have time to review anyway, does anyone have a kind of problem you want to review? I'm not stopping, we're not having a study hall, you had enough of that in the last days. You gotta really focus in and get going. So who has, it doesn't have to be what's on the quiz, it can be another kind of problem. But if it's one like we reviewed earlier, we can certainly do that again now too. Is it?
Can we go over the, questions still on the 4.5 homework, like, the graphing one? Like the, 1/2 secant, 1/3.
Yep, we can do another graph, that's on our quiz. So the one in the homework was, oh, wait, that's not right. Yeah, okay, I gotta factor that 1/3 out. In the beginning, that was 1/3 x plus pi over 8. So when I pull out a 1/3, that's like dividing by 1/3, which is multiplying by 3. So if I take 1/3 times 3 pi over 8, I get the original pi over 8. You have to factor that number out. I'm sorry that you don't want to deal with a fraction, but you have to factor that number out. Because that is your phase shift. So whatever this thing looks like, it's starting at negative 3 pi over 8. Okay, so what does it look like? Well, whatever it is, it's positive. It's a secant. Everybody does this his or her own way. I cannot do secants, I have to do cosines first. So I'm gonna sketch in a positive cosine, like a skateboard ramp. Ooh, that's what a positive cosine looks like. Its amplitude is a half of the cosine. The amplitude of the cosine is a half. And the period is 2 pi divided by 1/3, or 6 pi. Or for purposes of this problem, I might think of that as 48 over 8. What's 48 divided by 8? 6. 6 pi is 48 eighths. Why did I think about it like this? Because I have to start at negative 3 and add 48 eighths. Add a period. So I started at negative 3 and added 48, that puts me at 45. Period is distance start to finish. So if I'm starting at negative 3 and I'm traveling 48, I'm stopping at 45. Right in the middle of negative 3 and 45 would be 221 pi over 8. Negative 3 and 21 is 18, so that's 9 pi over 8. Obviously my scale is a little off a job. 21 and 45 is 6633 pi over 8. That is a beautiful picture of the cosine. But this isn't a cosine, it's a secant. So wherever I cross the x-axis, which is these two places, I'm going to draw an asymptote, and then this hill is going to become a valley, so I put my pencil right there at the top of the hill and make it up. This one's going to come down, put my pencil right there and come up. That red thing is the secant. Except for this, right? So now I have to take all these points, basically this one, this one, and this one, and they're gonna go up one. So if that's a half, this would be 1, this would be 3 halves. So he's coming up here, asymptotes aren't changing. Now that thing is up here. This one is clear up here now. And this one got moved up here too. So the purple thing is the final answer. Period is 6 pi. Amplitude is 9. Phase shift, negative 3 pi over 8, and vertical shift, positive 1. Okay, Izzy?
Can you repeat the vertical shift? The 1.
All right, anybody else think there's something that you want to ask about? I'm going to keep blabbing, so you might as well have me blab about what you want me to blab about. Donovan?
Can we do number 2 on 4.5?
Solving the equation with no calculator. Root 3 secant plus 2 equals 0. So secant is going to be negative 2 over root 3. So I subtracted 2 divided by root 3 just like a regular equation. Now, if the secant is that, then the cosine is this. You don't have to make that change, but I think better in terms of cosines because I haven't memorized SOHCAHTOA.